All right, continue with number 97. We're solving here. So what we're going to do is subtract 13 of both sides. So I get 2 to the x equals 22. And then I want to introduce some sort of a log to get the power down. So I'm going to do log base 2. 2 to the x equals log base 2, 22. So x equals, now over here I'm going to want to get a decimal on this, so I'm going to use change of base. I'm going to use ln's here. ln. So if I did in my calculator ln of 22 over that, it comes out to about 4.459. Okay, looking over here at 99. First thing I want to do is divide by -4. Five to the x. Divide those out, and it comes out to about, I think, 17. Okay. Same thing here. I'm going to use log base 5. 5 to the x equals log base 5, 17. This gives me x, and I'll use change of base again. So the ln of 17 over the ln of 5. Okay. 101. And this says 2e to the x minus 3 minus 1 equals 4. So I'll add a 1 to both sides. Divide by 2. And I'm looking at e to the x minus 3 equals 5 halves. And so here I got this e, so I'm going to take the natural log of both sides. And then, so kind of coming up here, what I'm going to have is just x minus 3. Right, these are our inverse, right? Equals the ln of 5 halves. Okay, remember this is one quantity here. And then I'll add a 3. And then I can just punch that into my calculator. Right, and so punch that into my calculator, then add a 3. Okay, and that comes out to about 3.9. 103 looks like e to the x minus 7 e to the x plus 10 equals 0. So this is a quadratic. So I'm going to say e to the x and e to the x. What multiplies here? So it's going to be a -2 and a -5. So they're still equal to 0. I'm going to use zero product property, setting those equal to 0. So I get e to the x equals 2, e to the x equals 5. Take the ln of both sides. Alright, so this is x equals the ln of 2, which is about 0.69. No, sorry. Yeah, about 0.69. And then the ln of 5 So these cross out is about 1.6. 105, the ln of 3x equals 6.4. So seeing that I have a log, I want to introduce or raise them to a base that is the same as the base in the log. So this is log base e because it's ln. So this is an inverse right here. So 3x equals e to the 6.4 divided by 3. Okay. And then I punch this into my calculator, e to the 6.4 divided by 3. That should come out to about 200.6. 107, the ln of x minus the ln of 5 equals 2. So I want this to be like the problem I just did in a sense, but I got to get it down to a single log first. So I can use a quotient property here. Then raise it to a base e. And so I get x over 5 equals e squared. And then multiply both sides by 5. Oops. Kind of where I was at. I was at like right here. All right. Multiply both sides by 5 and x equals 5. Oh, sorry, that was to the 6.4. And once again, I can punch that in my calculator. Oh, sorry, that was a squared. Sorry, multiply that by 5, so my answer is this. Sorry. E squared, punch that in my calculator, I can get an answer on that. Okay. Looking at 109. All right. Equals 2. So I got a couple of different ways that I could go about doing this. So the first thing, I'm going to go ahead and turn this into a rational exponent. Use a power property. Okay. Now from here you can get kind of weird because I want to put this up in the power with a base e, but this half's kind of screwing me up. So what I'm going to do, just to make my life a little easier, is I'm going to multiply both sides by 2. So that means this goes away, and now I'm just the ln of x plus 1 equals 4. Now I raise everything to a base with the base of e. I can squeeze it over here, so now I get x plus 1 equals e to the 4th. Subtract a 1 to both sides, and it's e to the 4th minus 1. 111.